All right, so let's do this. Hey, my name's Christian Horner, and I am here to help you review a little bit for the AP Physics 1 exam. So let's check and see how everybody's doing, and we'll just kind of go from there. And I'm going to have to turn off my recording here because it is 100% echoing a little bit. All right, here we go. So the thing that I love to do in order to get you started is I want you to be super interactive here. So I'm going to put a link in the chat. And what I'd love for you to do is join that. Some of you have used Pear Deck before. And so you can go ahead and log on. You kind of know what to do. So there is the link, and then there is a code, and that code is TQFDBA. So once you log into joinpd.com and you enter with your Google Mail or Google account, then you should be able to go ahead and log right into this. And it looks like we've got 13 people, so it's so awesome to see all of you. And we will get you started. So I'm going to tell you a little bit about me. My name is Christian Horner. I am a physics teacher in Westfield, Indiana. I am also a AP Physics College Board reader. So I actually read all of your AP Physics, well, not all of you, but I do read your physics exams, and it's super fun to do. So I've got a little experience there, and I'm going to use that experience to help you out just a little bit. So once again, welcome. This is AP Physics 1, and we are going to go ahead and get started. So as people come in, we will keep getting you in there. And Brianna is in. Hi, Brianna. It is so good to see you. Hey, Brianna, if you don't mind, every once in a while, if you don't mind putting in the joinpd.com and then typing in that code, that would be fantastic. All right, here we go, everybody. So this is how it works. Once again, I am Christian Horner. Our TA for today is Brianna. Brianna is a phenomenal student who did extremely well on the AP Physics 1 exam. So we are going to have her chime in every once in a while. She's going to be watching the chat and helping us out. Heads up, we are recording this stream, and it might appear on our website, so fiveable.com. It might be on YouTube or other public channels. So just know that you're going to see it there. Some upcoming live reviews that we're going to do for AP Physics 1 on March 8th. We are going to take a look at dynamics. And then on March 15th, we are going to do circular motion and gravitation. I will tell you that we also have Peter here. Peter does AP Physics C. So if you're interested in AP Physics C, stop on by and take a look at what Peter has for you. All right, here we go. Remember, tell your friends about Think Fiveable. Okay, go out there, tweet out, let us know how we're doing, and let everybody know what's going on. Yes, Alex, there will be a review for every unit. Remember, AP Physics 1 students, that they did drop the last 3 units. So that's an awesome thing. You'll be able to just keep going. All right, here we go. So in this stream, we're going to talk a little bit about position, distance, and displacement. We're also going to take a look at speed and velocity and what the difference is. We'll definitely take a look at acceleration. We're also going to look at motion maps and how they're used on the AP Physics exam. We're going to take a little bit of a look at plus minus velocity and plus minus acceleration. And this is where we talk about things that are speeding up and slowing down. And that's super important because there are a lot of times when they go through and ask you about speeding up and slowing down. We'll do some acceleration graphs, and then we're going to have some time with whatever is out there to just practice. So, hey, we really appreciate y'all coming in. And if you want to get on to the Pear Deck and do some things here in just a little while, we will get you on there. Position and distance. So let's take a look at position and distance a little bit. And when we do that, what you're going to notice is we're going to try to figure out what is position. So position is really just the placement or the spot where an object is located. So it might be at A, it might be at B, it might be somewhere in between. The positive position and the negative position. So when we think about positive and negative position, we always look at the zero. And the zero for what we have here is right here in the middle. So this would be zero. And then it's kind of hard to see the numbers underneath. I probably should have lifted that up a little bit, but this goes 1, 2, 3, 4, 5, 6. So B is at 6. And A is at -2. So positive is to the right. We know negative is to the left of the zero. Distance is the absolute value from one point to the other. And we call that a scalar. So that is what we call a scalar, and it is path dependent. So it depends on not just where we start and where we stop, but which way we go as we go from one to the other. So let's do this. I'm going to have you, when you look at distance, that is the total path. And we're going to start at G, and we're going to start at G and move to A. And then we're going to start at A, move to F, and then back to C. So let's do this first. What is the distance if you go from G to A? So now the cool thing is I can see all of your responses. There's a lot of different ways you can do this. You can either type using the text tool. You can also just draw if you want to. I will show you some answers to some various people. Just know I will not show your name, okay? So I will not show your name at all. But I'd like for you to tell me how far is the distance from G to A. And then I also want you to tell me how far is the distance from A to F and then back over to C. So I'm seeing some awesome answers here already. You guys are doing a beautiful job. So we're looking at the distance from G to A, and then the distance from starting at A, moving to F, but then moving back over to C. So remember, distance is the total path. So when you do this second one and you go from A to F and then back to C, make sure you add all those together, and that will totally help. Distance, remember, is a scalar. So we're not too worried about positive and negative here. Instead, we're just worried about the total number of steps, meters, centimeters, miles, kilometers, light years that we go. So those are the things that you want to think about. All right, you guys are doing awesome. We still have a few more people to answer this one, which is fine. But let's go ahead and start taking a look at what some of you have written. So to do that, I'm going to just show the responses. And you'll notice that we've got 17 and 19. So that's our first person. Our second person says 17 and 17. And our next person says 17 and 19. So we've got some good responses here. Here's 18 and 20. So let's take a look and see what the actual answer is. So the actual answer for this one for distance, if I go from our first position, so remember we went from G to A. If I go from G to A, that is 17 units. Notice there's not a negative there. And there's not a negative there because we're not worried about direction. We just want to know what is the absolute value of the distance. For the second one, remember, we went from our first point, which was A. Then we went all the way over to F, and that was 12 units. And then we went from F over to C, and that's 7 units. So all we had to do was add those. It's super important that you're able to do this. So you have to think about distance versus displacement, because on the AP test, when we do things with speed, it's really super important. All right, here we go. Let's take a look at the next thing. So on the next slide, this is displacement. So this is the point to point, regardless of path. So I want to go from G and I want to move to A, okay? And I really want you to figure out, so instead of distance, like it says here, let's do displacement this time. So instead of distance, let's go ahead and do displacement. So we want to know from G to A, what is, and be careful, we do want displacement this time. So instead of distance, we need to do displacement. Remember, displacement does have a direction. So if you go from right to left, you definitely want to make sure that you put in a negative value. And then when we go from A to F to C, always think about where you start and where you stop. So you guys are doing awesome. I'm seeing a lot of great answers so far. This is beautiful. Lily, you're doing great. Love what you're doing here. So Julia looks good. Kayla, we've got Manar, very good. Alicia, very good. Excellent. Chicken Nugget is in the house, it looks like. I love it. Alex Miller, very good. Okay. Caitlin, you're doing great. Sana, excellent job. Andrew is doing well. Good job, Kurt. Excellent, Kyle. Alejandro, very good. Sarah, nice job. Folks, you're doing awesome. Keep it up. This is what we like to do, is we like to keep you active and involved so that you are really learning. Once you do this for G to A, go ahead and do it for A to F to C. But remember, we're doing displacement this time. So we just want to know from where we start to where we finish. All right, good job. Let's take a look at the answers that you guys have so far. So here we go. Let's take a look at some of these answers. We're going to do it more of a grid layout, and there's a lot of answers here. So let's see how many are the same. I see a lot of negative 17, or like this one, somebody said 17 units to the left. So that is absolutely phenomenal. So we definitely want the negative 17, or we want to say 17 units to the left. So that's really good. Next one was A to F and then back to C. So remember, we always start and then we go right to where we finish. We don't worry about the path. And that one is positive 5 units, or 5 units to the right. So you guys are awesome. So here we go. This is our person that has done the units to the left and the units to the right. Beautiful job. You guys are rocking this. This is awesome. Let's go ahead, and here are our answers again. So you'll be able to see this when you go back into the video, so you can kind of take a look at what's going on. So beautiful job. When we're done, I also will have a way that you can get all of your answers in a Google Doc. So we'll do that right at the end. We'll put that link in the chat so that you can have this whole thing. All right, so now we're going to take a look at distance and displacement, but we're going to apply it to a track. So there's a track down below, and the track is 100 meters from start to stop. So the start finish line, you'll notice, is down here. I want to know the distance around the track, and I want to know the displacement around the track. So let's give you about, 20 seconds, and go ahead and put in the distance around the track and then the displacement around the track. So just trying to apply it a little bit more. So we're going to keep building what we're doing. I'm checking out on Pear Deck what you have done. You guys are doing awesome. So ladies and gentlemen, it looks beautiful. This one, notice we do have units. So please do not forget your units when we go through and we actually grade your exams. We want to 100% make sure that you do have units so that we know what you're talking about. Huge difference between meters, feet, centimeters, micrometers, megameters, all those different things. So make sure that you have your units just right. All right, looks like everybody's doing really well on this one. Here are some of our answers that we have. So the distance is 100 meters. So we have several people here that have 100 meters. That is beautiful. And then the next thing that we see is that the displacement around the track is 0 meters. Remember, the displacement is where we start, measured to where we finish, but we don't worry about the path we took. So because we started and stopped at the same spot, then you'll notice that we didn't go anywhere in terms of displacement. That is 0 meters. So that's super important for what we're about to do next. So here are those answers again. We do see that it's 100 meters and 0 meters. And now we're going to talk a little bit about rates. So AP Physics 1 is full of rates. We think about speed is a rate. It is a scalar. It does not have a direction. So if you think about just speed, that is a scalar, and there's no direction. Speed, we know, is distance divided by time. And if you look at the AP Physics 1 equation sheet, you'll notice that there is not an equation for speed on that equation sheet. And so that's the really super important thing. Velocity is also a rate. However, velocity does have a direction. And so velocity is the change in position over the change in time. And if I go from a position of like maybe 5 and then I go to 1, you'll notice that my final minus my initial, I might get a negative number. So 1 minus 5 is going to be -4. If I do that in a second, you'll see that. So we want to be careful because delta x is displacement. Let's go ahead and try this one. So we're going to look at speed and velocity. We're going to have to go through and we're going to figure out what in the world is the speed if the trip time is 50 seconds. Again, this is 100 meters. We're doing this in a time of 50 seconds. So I want to know what is the speed, and I also want to know what is the average velocity. And don't forget your units. So I'm taking a look at what some of you are doing, and it is really good. Excellent job, Madeline. Yeah, very good. You guys are, this is awesome. Gabriella, very good. Kurt, excellent. Isabel, nice job. Caitlin, very good. Good job, Tom. Some of you I recognize. This is awesome. Alejandra, very good. Chimney, very good. All right, so we're getting some great answers here for that. Don't forget about the average velocity if the trip time is 50 seconds. So I'm seeing a lot of really good answers here. This is beautiful. Way to work. Just some really basic things that we've got to hammer out here before we can move on. So just making sure that this is looking good. And it is. Excellent. Let's take a look at some of these responses you all have. This person actually showed us some math, which I absolutely love. On the free response questions, you need to show everything, including your equations. So this person said 2 meters per second for the speed. That is correct. And then we also want to look for what is the velocity. And because technically we didn't go anywhere, our velocity is 0 because we have 0 in terms of our displacement. Divided by 50 is just 0 meters per second. So those are the correct answers. Let's go ahead and let's just make sure you see those correct answers on this slide. So what I did do is when you get done and I give you the link, you'll be able to see your responses as well as all the correct answers and kind of how they work out. So that's a good thing. Motion maps. Motion maps are used on the AP exam to try to show you visually how something moves. So if I am moving in this first example from left to right, you'll notice that the dots occur at each one of these positions. So if this is 0 meters, then I would have 1, 2, 3, 4, and 5 meters. Each one of the dots represents a time. And so the first dot is 0 seconds. The second dot would be 1 second, then 2 seconds, 3 seconds, 4 seconds, and 5 seconds. This one is constant speed because for every second, I have the same amount of space between the dots. So we say that that has a constant speed of 1 meter per second. Now, if we look at the next one, we would say that our velocity is now negative 1 meter per second because our speed, we look at it, we have speed of 1 meter per second. But now if we put the negative direction in front of it, that is our new velocity. So those are what we call motion maps. And that's what those motion maps look like. For acceleration, acceleration is a change in speed. If I increase speed, that means that I have a positive velocity. So I might be moving, for example, to the right, and I'm accelerating in the same direction to the right. It might be a rocket that is moving up and accelerating up. So that's increasing speed. But you can also increase speed with both velocity and acceleration being negative. And a lot of people say that negative acceleration is slowing down, and that's not true. If you base jump off of a bridge and you're falling in the downward direction and you have a velocity in the downward direction, we say downward is negative, and your acceleration is also negative, you will speed up in that direction. So be really careful when you think about what's going on here. Decreasing speed means that your two signs are opposite. So you either have positive velocity and negative acceleration, or you have negative velocity and positive acceleration. So just be really careful there. If you have a change in velocity, that doesn't always mean that your speed is changing. So if I go around a roundabout, so where I live, we have a lot of these little places in the road where instead of having a stop sign or maybe stoplights, they have made it so that we can just drive, kind of like in some of the European countries. You can drive around and take your turn. So we call those roundabouts. As I go around that roundabout, sometimes I like to just go out and drive around the roundabout at a constant speed at like 30 miles an hour. If I do that, I am moving a constant speed, but because my direction is changing, my velocity is different. So that I do not have a constant velocity. So let's look at two examples. One of them is speeding up and the other one is slowing down. In the top picture, the dot diagrams or the motion map shows that this object at each second is increasing the distance between each dot. That means it's got to be increasing its speed to the right. The acceleration is also to the right. And you'll notice that these dots all have the same size arrow, indicating we have a constant acceleration. In the one below, I am moving to the right, but you'll notice that the dots are closer together as I go left to right. So in this dot diagram or motion map, you'll see that because I have dots getting closer together at each second, I am slowing down. So the acceleration is actually pointing to the left. The arrows are the same size because I have a constant acceleration. So that works out really well. Let's go ahead and take a look at the next slide. So for this one, it just goes through and summarizes what we just said. In these four different scenarios, I have positive, positive, or if I have negative, negative, I know that object is speeding up. If the signs are opposites, I see that the object is slowing down. So let's do some things with this. Let's actually go through and figure out if this object is really truly accelerating. If it is truly accelerating, okay, then we know that the velocity and acceleration are both positive. Here is the first thing I would love for you to do on this slide. I want you to go up to the very top here, and I want you to draw two circles right above the curve. So right above the curve, I want you to draw two circles. So one circle right here, and then one more circle right here. When you're done drawing those two circles, I want you to put dots, one dot inside of each circle. And as soon as people do that, I'm going to show you kind of what that looks like if you've done it right. So we're going to draw two circles, one here, and then we want to put dots on the insides of those circles. So we'll see if anybody's done it here or not. And we're doing it right on top of that curve. So we're going to put a couple circles and then a couple dots. Oops, I saw one right there. So this one looks good. So we'll project it. If you do that, notice that this graph looks like something is smiling. And so when I have a position versus time graph and it is smiling, that means immediately I can go down to the bottom where I have my acceleration time graph and I can make it positive. If this is smiling, just like we see in this picture here, you'll see that we do have a positive acceleration. So anytime it's smiling, one more time, I know I have a positive acceleration. The way that I have to figure out the velocity graph is a little bit different. What I'm going to have you do next is I want you to draw a straight line. I'm going to have you start over to the left of the word position, and I want you to make a tangent line with the very beginning of the curve. And it's probably going to be a straight line left to right. So go ahead and draw a straight line left to right, right at the very beginning here. So draw a straight line left to right, right here. And then I'll project that so everybody can see it. It is very creepy to see this, but I really like it. I think it works well. So if somebody can draw a straight line left to right, right here, and then we're going to draw another straight line tangent to the curve right here. So we're going to draw one straight line left to right, right here, and another one right here. So we're going to have two tangent lines. So let's see if anybody has done that. There's one that started. So we want two tangent lines right at the beginning and another tangent line right at the end. And I'm starting to see it a little bit here. Getting better. Oh, there we go. There's a perfect one. Okay, so I'm going to show everybody this one. You'll notice that this person has drawn a tangent line to the curve at the beginning and at the end. So now this is how we do the velocity versus time graph. Notice the slope of this line. So the slope of this line is 0. So I'm going to start my velocity at 0. And then I'm going to come over to this line, and I see it's very positive, has a very positive slope. Remember, the slope of a position time graph is the velocity. And so because this has got a positive slope, we're going to put a dot right here and then connect the two. So because it's smiling, we said that it has a positive acceleration. And then if you draw your line at the beginning, a tangent line at the beginning, and a tangent line at the end, you can put in two dots. One dot right where the velocity is 0, and another dot where we have positive velocity. And then connect the two dots, and you're done. Now we can describe this motion. We just said this is an object that accelerates in the positive direction, starting with 0 velocity at position 0. These are really important to be able to do. We call these stacks of kinematics graphs. And you'll see these probably on multiple choice. Sometimes they'll use these on some of the free response, but multiple choice, there's a lot of these sometimes. All right, awesome job. So let's go ahead and go to the next one. Let's do the same thing. I want you to put two dots. Always put it above the curve. So always put your two eyeballs right above the curve. And then I want you to draw a tangent line right in front of the position and another tangent line right at the end. So we can see what the velocities are. Somebody just did it and they erased it, but it was perfect. Afia, if you can put those back, that would be awesome because you had them right. And now I've got everybody drawing eyeballs, which is beautiful. I love the eyeballs. I think the eyeballs are super, super important because they help you see whether the acceleration is positive or negative. So remember, we want to draw on this first part of the curve, we want to draw a tangent line. So the tangent line for this one, notice, is going to point up and to the right. And then the second tangent line is going to be straight across. So I'm going to look and see if I can find one that somebody did. And we will, very good. So here we go. So I've got a couple of them that look really good. And we'll pull these up and show you what they look like. And so now we can see we have somebody that's drawn a tangent line. This is super positive here. And then we have a 0 slope. So we have a big positive velocity, and then that goes down to 0, and then we just connect our two dots. So now I know the velocity went from positive to 0. So that's a really good one. This one is even better, and it's because they really have a nice positive slope here, and then they have over here a 0 slope. So we went from positive velocity to 0 velocity, and then you just connect your lines. Notice it is sad, and because it's sad, we've got to have a negative acceleration. So hopefully that's super good. All right, I just saw somebody say, is the audio gone? Can everybody hear? Okay, good. I just want to make sure everybody can hear. Let's go ahead and take a look at this object. It is slowing down, or it's accelerating in the negative direction, starting with a positive velocity at position 0. So it's like you're coming up to a stop sign, and you should be set. All right, good job. Let's go on to the next one. So here's another one. Do the same thing. I want you to put circles always above the curve. I want you to see that this one is sad, and it is sad because we know that our acceleration is negative. The other thing I want you to do is do once again, notice that the tangent line to the curve for the beginning of the position versus time is 0. And then here, the position versus time is negative. So here we've got a 0 slope, and then here we've got a negative slope. And it looks like, oh, that's an awesome one. Very good. There's a couple of them that are great here. You folks are doing beautiful. So let's take a look at these couple that you're doing because they look so good. And one of these is spontan. So excellent. I love this. Let's take a look. Here we go. You'll see that we approximately have 0 velocity at the beginning, and we have a negative velocity here. So we took a dot, put it here for that 0 velocity, and then we have a negative velocity, and it is frowning, so we know that the acceleration is negative. So excellent job. Excellent, excellent job. Same thing here. This person did the same thing. I actually like what they did. They did this like a mustache. So we did straight across, and we did another one that is tangent to the curve. And we've got our 2 eyes, and we can kind of see what's going on. So this one is speeding up in the negative direction. So instead of going to the right, this object we could say is going to the left. Or you could say it is moving down. It started at 0 and then it fell. Excellent job. Hey, hopefully that's super helpful, and that's helped you see a little bit better kind of what's going on. So that's what we're hoping. Let's go ahead and take a look at this next one. So this is the last one before we start doing some actual AP style questions. So hopefully this is super helpful. Let's do this one. This is one where we have an object that is slowing down. It's accelerating in the positive direction. So it's moving to the left, but it's slowing down. So it has a big velocity at first and then 0 velocity because it's going to stop. Draw your eyeballs again. Remember, they should always, always, always be right above the curve. And then draw your 2 tangent lines. So your first tangent line, notice, is going to go down to the right, and your second one is going to go straight across, left to right. So hopefully that's helpful. You really can do this on the AP test. They will not mind. You are using something to help you remember what this is. So please, please, please see that. I think that's just super awesome that you guys are doing this so well. Here is a really great answer here. So I'll put this one up. Notice we've drawn our 2 tangent lines. We've drawn our eyeballs up the top. We notice that it is smiling, so we have positive. I love the little smile there. We do have a negative velocity, and that's going to a 0 velocity. And thank you so much for putting the dots on there. That is excellent. Brianna has put an excellent little blurb about what tangent means. And it's important that you understand that, because that way you can see what the velocity is of a position versus time curve. So you can kind of see how that velocity goes from very negative here to 0 right here. Hey, you guys are doing awesome. We still have about 27 minutes left. So we're going to practice now. I think you know what you need to know in order to practice. So for this one, I'm going to ask you a few questions. I want to first have you tell me, when is the car at rest? Label anywhere where the car is at rest with the word rest. And it could be one place, it might be 2 places, it might be 3 places, it might be more. So I want you to label where this car is at rest. Then I want you to label when the car is speeding up, and also when the car is slowing down. So you can either type using the text tool. I'd change the color so that it's something that you can see. Or if you want to, you can just use the drawing tool, Totally up to you. Does not matter to me. I want you to try. So everybody try this. It's okay to be wrong. It's okay to get these wrong because you're going to learn a lot more than if you get them all right. So you guys are doing fantastic. You guys are absolutely doing fantastic. I'm looking at the chat too. Thank you, Brianna, so much for going through and answering all these awesome questions. And thank you so much for everybody asking questions. Thank you, Sophia, for answering questions too. That is just beautiful. I love what some of you are doing. Some of you are using color coding. And so I can see that, and that just looks beautiful. Yes, Spondan, excellent. I love it. You guys are doing fantastic on this. This is an actual AP question. This was used one year. And so they really are trying to check and see if you understand what the constant velocity is, when something is speeding up, when something is slowing down, and doing all those good things. So be really careful when you do this one. So just make sure you check what is on each one of the axes. I see some awesome responses here. You guys are doing great. Hey, just to let you know, don't forget at the end of this, hang around for just a little while because we will give you a link that will give you this entire presentation. It'll show you how you answered, and it will also show you what the right answers are. So hopefully you'll look forward to that, and that will be something useful. The other reason we do that is just in case we don't get done, you'll be able to see the rest of what's going on. All right, I'm seeing a lot of really great answers here. And I'm going to give you another 10 seconds or so to get what you can done. But I'm seeing some awesome answers. You guys have done it all so fantastic. This is beautiful. Awesome job. I'm actually going to lay all of these on top of each other so you can see all the things that everybody's done. All right, here we go. In 3, 2, 1, blink. There we go. So this is the cool part. This is everybody. So there are a lot of you on here. 52 people are using this at one time, and you can see what everybody did. So what I'm going to do now is I'm going to take it back, and we're just going to look at individual ones. So this one's really good. I love this. This person has gone above and beyond. They said that the velocity is greater than 0, so we see this, but the acceleration is negative. So this one, as it goes from here to here, is slowing down. So this one is speeding up from here to here. Here we see slowing down. And then we have, something interesting, constant velocity. And then this one is slowing down and then speeding up. And then this one, constant velocity again. So really good job on that one. And we've got some other answers here. People have just done a really good job kind of going through color coding, kind of showing us what's going on, telling us when this object is at rest. Now, I will tell you, be careful, because this one is velocity versus time. And if we did position versus time, the answers would be a lot different. So you have to be really, really careful when you go through and do these. So excellent job. What I'm going to do is I'll go to the next slide. This is the slide that kind of shows you what all the answers are. So it is at rest at these 2 points here. It is slowing down, then speeding up, then slowing down, and speeding up. These spots right here where it's horizontal, these are constant velocity, and I didn't have you label those. Let's go ahead and take a look at the next question. So our next question wants you to briefly describe how you would find the horizontal position of the cart at 7 seconds if the cart is located at 3 meters when it starts in T0. You do not need to solve for the final number answer. This takes me to a really important thing about the AP Physics 1 exam. It is not like the AP Physics C exam where the really important thing is for you to find a final answer. Instead, in AP Physics 1, we value what you write. So what I would like for you to do is just do exactly what the question asks. Describe how you would determine the position of the cart when we get to 7 seconds. Notice this is a velocity versus time graph and not a position versus time. So you need to be very careful with this one. How would you find where the object is if it starts at 3 meters when it's at 0 seconds, and then it travels for 7 seconds. So I'll give you a little bit of time. Use the text tool. So you'll see over down on the bottom left, you'll see that text tool. And I would love for you to go through and just type out what you think you would have to do to be able to find that position. If you want to write it, handwrite it, you sure can. That's totally up to you. But you're trying to describe how you would find the position of the cart at 7 seconds. So we're going to give you, just a little bit of time here to do this. If you want to draw some things on the graph and refer to that, you can do that. Totally up to you. But remember, the AP Physics 1 test is really big into having you explain things and not just solve stuff. They want to make sure you understand the physics, because some people are really good at guessing. Other people are really good at explaining things. So that's what we're going to keep doing. I am seeing some awesome answers. You guys are doing fantastic. And what I like is there are a lot of different ways to explain this. So I see a little bit of calculus. That is beautiful. So Yasis, that's very good. Okay. You can use calculus on this test if you want to. You just have to make sure that you explain in words what you're doing. So that's really important. So Afia, very good. Alicia, very good. Okay. So we're looking awesome here. I'm reading these responses and you guys are doing, oh, I love it. Very nice job. Okay. So I'm going to star some of these because you folks are doing beautiful here. I think I also want to grab this one that's got a little bit of calculus in it. So we're going to grab that one. And let's see. Excellent. Nice job. Oh, this is beautiful. You guys are doing beautiful. I love it. There's another calculus answer. Absolutely fine to use calculus if you want to use calculus. Good. I love it. Yes, very good. So that's a good part of an explanation. So it looks good. Yeah, and then we've got some people that are using equations too, but they're using the equations to explain what they're doing. So I absolutely love that. That is beautiful. All right. So what I'm going to do is I'm going to go ahead and I want to show you some of these responses that people are doing. So here's one of the calculus ones. If you do the integral, okay, so if you do the integral or take the area under the curve and add the initial location of the cart to the value of area under the curve, you are 100% correct. And that would be how you would do it. So remember, you don't have to solve for the final answer. You're just explaining. So this is a really good explanation that includes calculus, but you do not need to use calculus. This person did not use calculus. Notice that they went through and they talked about what they would do. So they're looking for what the displacement is, and that is the area under the curve. So we look at the area here and we look at the area here, but notice that the area from here to here, this area is negative. So if I add the two areas together and then add the 3 to it, that will give us what our final answer is. But you don't have to give the final answer. That's the beautiful part of this. Here's another one where somebody else has done calculus, and that's absolutely fine. Do make sure that you explain it, and that makes it really good. Here's somebody talked about finding the two areas. If you're not sure how to get this initial position in there, that's okay. You've talked a little bit about this, so you are going to get partial credit. Really important that you do the best you can to explain things. This person went through, found the slope, and then used kinematics to solve it. So just another way to do it. These are just awesome answers. And this is why I love to kind of see everybody here doing it a little bit different way. So beautiful job. You guys are doing such an awesome job. Here is the answer that I have. And you're going to notice that when I answered it, I used what I like to call basic physics, which is the B, side evidence, which is the C, and then draw everything together. And that's what I did. So I talked about the area under the curve of a velocity versus time graph is the change in position for that object. I'd start with 3 meters, add the area from 0 to 4 seconds, and then subtract the area from 4 to 7 seconds. And then I just drew it together. And I said, since the total area under the curve is the change in position, adding that total area to the original position will give the final position of the object. So just another way that you can do it. Excellent job. You guys are doing fantastic. Now we're going to do the same type of thing again. I want you to briefly describe how you would determine the acceleration of the object from 0 to 9 seconds. This one should be a little shorter. This one won't take you as long to do. So take your time. I want you to tell me what is the acceleration of the object from 0 to 9 seconds. And I'll give you just a little bit of time to get this one down. You guys are doing fantastic. I really appreciate all of you being here and doing such a great job. This should be a pretty simple test for you if you go through and do these. It is not required for free response questions. So what I just showed you is just a good way to organize your thoughts. That's one way to do it. Some teachers will have you do claim, evidence, and reasoning. But if you want to use basic physics, cite evidence, and draw it together, you sure can. You can do whatever you've been taught as long as you're going through and really trying to show you understand that process. All right, let's take a look at the answer that you have here. So I'm going to show some responses. So I love this. The equation for acceleration is velocity divided by time. So all we have to do is find the acceleration by finding the slope of the graph. That's a perfect answer, and that would earn perfect points. So very good job. I did the same thing again. I went through and used B, C, D to try to explain what to do. So you can kind of take a look at that when you get this little presentation at the end. All right, we're going to move on just a little bit more. Here we go. I'd love for you to briefly describe, and I know we're doing a lot of this, but this is really what this test is like. Describe how you would calculate the acceleration of the object from 2 to 4 seconds. Notice that I've given you 2 things. One of them is a position versus time graph, and the other one is a velocity versus time graph. So totally up to you which graph you want to use. You can use one, you can use both, however you want to do it. So I would love for you to go through and figure that one out. And you're doing good. Yes, these are the kinds of questions that you should expect in the free response section. They will mainly be things where you're going to have to go through and explain what's going on. So that's typically what you'll see is it will have you really go through and just explain what's going on. So I just want to make sure everybody can still hear me okay. Kind of had a hiccup here with the internet. So I just want to make sure everybody can hear me and everything. So hopefully everybody can hear me. And everything's still going really well. All right, we'll just keep going here. Okay, good. I just thank you so much for letting me know you can still hear. Perfect, perfect, perfect. That is a great thing. All right, so let's take a look at some of your responses and what you said. So here we go. This is a good one. So we found somebody here is finding the slope. Somebody here is finding the slope, and they're finding the slope of the position, I'm sorry, the velocity versus time graph. So that is an excellent job. So very, very, very nice. I love it. That is beautiful. Thank you so much for doing that. And Now we're going to go ahead and move on. Let's take a look at the next one. So let's see what else people have put here. Use the sign of the velocity, ignore the position versus time graph. Good. So sometimes they'll give you things you don't need. Love it. Somebody else did the same thing. Very good. Excellent job. Yeah. Okay, cool. Let's go ahead and move on. Here is the answer. So once again, I like to do BCD. You don't always have to do that, but that is what you see. So you should be good there. All righty. Now, the next thing that I want you to do is it wants to know in which direction is the object moving during the first 5 seconds. This thing is starting at 0 position. Now, when we do this, here's the process. I want you to answer the question in the very top box. So I'm going to have you answer the question. In B, tell me what basic physics did you use? In C, cite evidence. So tell me, what is it that you see in the graph that allows you to do what you did to find the answer? And then in D, draw it together. So A is answer the question. B is basic physics. C is cite evidence, and D is draw it together. And I'll type that in the chat. So hopefully that helps. So answer the question, basic physics, cite evidence, and then finally draw it together. So that is what you want to do in a paragraph length response. And so that should be super helpful. And I'm starting to see some good answers. I like it. I like it. I love it. This is really good. I want to see how many of you catch what's going on here. Doing a great job. I love it. I love it. Good job. Excellent job. Good, good, good. Seeing some awesome answers here. Good, good. Beautiful. You guys are doing this right. Yeah, so you're learning a little bit more than just kinematics tonight. Hopefully you'll see that you're really learning that you've got to be able to explain things. So just knowing the answer is not always the key. The key here is be able to answer the question, tell what the basic physics is, cite some evidence if you're given a graph or anything like that, and then just really simply draw it together. So hopefully that's easy to do. I love this. So I'm seeing some beautiful answers here. Some beautiful, beautiful answers. So majority of people here are saying that the object, oh, here's a really good answer. I love that one. Okay, so most people are saying that this object is moving in the positive direction. So most people are saying that it is moving in the positive direction. But I want to show you what some other people are saying because this is really good. Check this out. This person said it's moving in the positive direction. They said if the object is accelerating in the positive direction, the slope is positive, the object has to be moving in the positive direction to the right. The graph from 0 to 5 begins by increasing acceleration that remains constant in the positive direction. But check this answer out. This person says we cannot know what direction since we don't know if the velocity is positive or negative to begin with. For example, the acceleration could be positive and the object still could be moving in the negative direction, although it would be slowing down. So very interesting. And then the next one says the object is moving away from the positive direction, but they didn't say whether it is got a positive or negative velocity. So do you see that? So here's the answer that we go through and typically give for this one. You could say that the car is moving in the positive direction as long as you give a good explanation as to why. Remember, the area under the acceleration versus time graph is velocity. So if I go from 0 all the way over to 5 seconds, notice the area under this part of the graph would give me a positive velocity. Because remember, the area under acceleration versus time gives you velocity. So if I explain it that way, I'm going to get points. The area under this is positive. And so finally drawing it together is just taking and restating A, B, and C is essentially what you're doing. So that's kind of what you want to see. All right, we could argue a long time about this question, but we're going to move on to the next one. I want to know at what interval or what time interval is the object at rest? And then when they ask you how you know, very, 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 very concisely, short, quick, easy to the point, I want you to tell me how you know, okay? So it doesn't have to be in complete sentences. It can be bullet points. So I actually encourage my students to write A, B, C, D on the test and then answer the question, literally put a dot, do basic physics, even if it's just a short little thing, side evidence, draw it together. Just really, really super easy to do. So let's take a look and see how you're doing. You guys are doing great. This is beautiful. So I want to know, when is the object at rest? I'm seeing a lot of correct answers. I'm so curious to see how you do on the basic physics, cite evidence, and drawing it together, because those are the super important parts. And when we get done with this one, unfortunately, it is going to be our last one. There's really, oh, you know what? Fortunately, it is the last one, so that's even better. So we timed this just right. You guys are doing fantastic, by the way. Seeing some very good. I like it. Very good. This one's tricky. So the area of an acceleration versus time, if you think about your units, if I take a meter per second squared and multiply it times a second, that would give me a meter times a second over a second squared. And then if you cross off your units, notice that you're going to get a meter per second. So that's how we know that the area under the curve is going to be the velocity of the object. So that is the change in velocity of our object. Excellent job. So let's take a look at what some people are saying here. We've got a lot of people saying something like this. The object is at rest from 10 to 13 seconds. And they're saying that it's because if an object has no acceleration, so no acceleration, there's not in motion, okay? That just means really that there's no change in velocity here. So here's what we need to do. We need to really kind of take a look at this next answer that somebody put. We don't know when the object is at rest. So if the acceleration is positive, negative, or equal to 0, the object can still have speed. So that's great basic physics. The graph only shows that anytime the acceleration is positive, negative, or 0, it doesn't really tell us hardly anything else. And then they were going to draw it together. So they're doing that right now. And they're doing a very, very good job of doing this. So we really don't know when the object is at rest because We don't know kind of what its speed was. If we think about it, the area underneath the curve is the change in velocity. So it has a very big positive change in velocity here, no change in velocity, and then a negative change in velocity. If the two areas are equal, then the object would go back to zero speed. But we don't see that. So this is probably a better answer than any other answer we could have. So excellent job, guys. Here's what we're going to do. Keep the conversation going. So if you want to hop over to Discord, we have a wonderful, wonderful Discord server, and you will see that there are several TAs there. So Brianna will be there at times. I'll jump on at times. Some of the other teachers will. Peter is in charge of all of our people, and he's doing an excellent job. So I love to see what we're doing there. I'm going to end this little thing here, but don't go anywhere because I want to give you a link so that you have access to the what you wrote and all of your solutions. So today is 3/2/2021, and I'm going to save and end, and then I'm going to put a link in the chat, and this link will give you access eventually to your this will give you access to your Google Doc. Okay, you won't see anybody else's, you'll just see yours. Okay, you guys have done an awesome job. Thank you so much for coming. I will see you again when we do dynamics. We will do the same type of thing where I'm going to go through, really make sure that you are engaged. We'll double check. If there's anything that's kind of weird in this one, I will fix it and go back. I think I need to explain some of these graphs a little bit better for you. So we will do that. When you do the link for Pear Deck, give it a little bit of time because it's got a process. But other than that, we should be good. So thank you so much for coming, guys. Thank you so much for joining the CRAMs. Go to the Discord channel and go talk more about physics. Good luck this week. Have an awesome week. Stay safe, and we will see you all later. Bye, guys. Have a great night. So the link should be in the chat. Are you all seeing the link in the chat? So I'll put the link here a couple times. Hopefully it comes up. So hopefully you'll see that link in the chat. I think it's going through. All right, cool. Awesome. All right, bye guys. Have an awesome night. I'll see you over on the Discord channel.